Liu, and I'll be your host for today. I'm on the TechnoWizards team 16458 in San Antonio, Texas. We were established 5 years ago, and we recently went to the Razorback Invitational Tournament in Arkansas. I'd like to give a big welcome to our guest speakers, Max, John, Derek, and Anthony from TechnoPots, team 8565, Sophie and Alex from ACP Free Wi-Fi, team 40657, Adrian from ACP Area 52, team 18227. Today you'll be learning about LegoCAD and CAD for First Robotics team, building mini-bots, Fusion 360, drive chassis, and more. If you have any questions during this meeting, please leave them in the chat below and they'll get them answered as soon as possible. Without further ado, let's get started.
Okay, hey everyone. So my name is Max, and I'll be the first.
Max, it's not your turn.
Oh wait, really? Okay, never mind then. My bad.
Okay, let me share my screen. Okay, let me present this. Okay, can you see my screen?
Yes.
Okay, so hi everyone, I'm Sophie from team ACP Free Wi-Fi 40657. So today, Alex and I are going to talk about LegoCAD, building your EV3 robot digitally. So these are our presenter bios, which is I'm in 6th grade. I'm at Greenhill School. This is my 3rd year in FLL. I like reading and writing. Alex?
I'm in 6th grade. I go to Rice Middle School. I have 2 years of FLL experience, and I like chess and Minecraft.
Okay. This is our today's agenda, which is first, I'm going to do a general introduction to LegoCAD software. Then Alex is going to do LegoCAD general features and a demo. And then I'm going to talk about building your EV3 robot digitally. Introduction to LegoCAD. What is LegoCAD? LegoCAD is a software and application used to design virtual models that you can build with Lego bricks. With LegoCAD software, it's possible to build an entire model in an imaginary space, letting you visualize properties like height, width, distance, or color before the model is used for a particular application. Why do we use LegoCAD? LegoCAD is easy to learn and use. LegoCAD has an intuitive interface that is designed to allow new users to start creating new models without having to spend too much time learning the application. At the same time, it has a rich feature set that enables experienced users to build models by using techniques that are more advanced. LegoCAD is LD Draw compatible. LegoCAD is fully compatible with the LD Draw standard and related tools, and reads and writes LDR and MPD files so that you can share and download models from the internet. It also uses the LD Draw parts library, which has almost 10,000 different parts and continues to receive updates. LegoCAD is cross-platform and open source. Native versions of LegoCAD are available for Windows, Linux, and macOS to ensure that users are familiar with the program interface. LegoCAD is open source, so anyone can contribute with fixes and features, and is always going to remain free. How can LegoCAD help us? LegoCAD can create 3D models. LegoCAD designs can be replicated almost instantly. LegoCAD designs can be modified quickly. LegoCAD files can be shared worldwide instantly. LegoCAD files are more secure than paper drawings. In our current situation, team members cannot meet often. Creating your models with CAD lets you share it with the team through email or Google Drive, so the team can still validate the robot design even without the actual parts in hand. When you want to change your robot design, it's much easier to make the changes with CAD rather than your physical robot. With LegoCAD's help, you can use CAD to organize your building instructions and designs. What if you forgot how to build your old robot? You'll never have to worry about losing that design. Next, Alex will talk about the general features of LeoCAD.
Hello, I'm Alex, and I'll be talking about the general features of LeoCAD. So this is the LeoCAD GUI right here. And this here is the workspace. It's where the model is built. And then to the right here, you have the tool windows. The tool windows are where there's like parts, properties, timeline, and colors. And then at the top, there are these toolbars. And they all have cool buttons that you can use to optimize building. And also at the bottom here, there's a status bar. It has X, Y, Z, movement, rotation, snap, and the step number. So now we're going to be opening a model with CAD. So if I go to File Explorer and Downloads, I have this file which I downloaded. And now I can't open this in File Explorer because then it's going to open as a file and it doesn't have a way to open that file. So if I go back to LeoCAD and then go to File, Open, and then you see here I have this file. If I double click it, then there it's open. So when you open a file, it looks like this. But how about if you don't want to look at it like this? All you have to do is right click and then go to viewpoints. Now there are a bunch of these. There's front, back, left, right, top, bottom, and home. And these are pretty self-explanatory. Front, left. Yeah, they're pretty self-explanatory. And say that's not all. You want to be able to look at your model in any direction. So all you have to do is click and hold right click and then move the mouse around. And then that will drag the rotation in any direction. And also, there's another way to move the model, and that's pan. So to pan the model, you go up here and then click this hand, and then you drag around, well, left click and drag around, and then that pans the model. And if you accidentally zoom out somehow, what you can do to zoom in is, you see my mouse here, if I scroll up, it zooms in. So if I scroll up, it zooms in, and if I scroll down, it zooms out. And next, we're going to be talking about steps. So over here in the timeline tool window, you can see there's a bunch of different instructions. And what these do is essentially they tell you how to put the model together. So this first, and then a bunch of those next. And also the parts window. So here you can see, say I want to find a gear. Well, this doesn't look very much like a gear, but that's because I'm searching in the wrong category. I'm searching in brick, but I should be searching in Technic because, as we all know, gear is a Technic piece. And you can see here, I have a bunch of gears. And now we're going to be using a website called Bricklink. So here I have the Bricklink tab open, and I want to find this this piece right here. So what I want to do is go back here and then Control F and then gear 12. And you can see this is a gear 12. And if I go back here, these pictures look pretty similar. And then if I want to put that into my model, all I have to do is copy this. So this is the gear 12. So all I have to do is go back to CAD and then gear 12. And then you can see here it is. So now we're going to be using the properties tab. So if I select this, then it has a bunch of properties like X, Y, Z, rotation, visibility. And so say, oh no, it's out of place and I want to put it back on to this axle right here. And this is at 86, -50, 291. So what I would do is change this to 86, change this to -50, and then change this to 291. And oh no, it's stuck. So I can just rotate it and then drag it out a bit. And now it's pretty much in. So that's how you use the properties tab. And that's all I'm going to be talking about. So next we'll have Sophie do a demo of our robot, Team Robot.
Okay, I'm gonna share. Okay, so now I'll show you our last year's Team Robot. We used LeoCat to design it, and this is the box spot from last year. So you can see it here that it's incomplete, so you can see the inside. And it's rear wheel drive, so I can climb up the bridge. There's color sensors to detect light and color. And there's also a gyro sensor, which helps the robot move and turn accurately. Here, this is the multi-step feature. It's a really important feature. And it allows you to create steps. It puts all of your pieces in steps. And it helps the people, especially builders, who understand how to build the model. So, okay. Next, I'll show you how to build an EV3 model digitally. So I'm going to share my screen again. Okay, now I will show you how to use some models to build an EV3 robot on CAD. So, a submodel is a group of parts that's approximately close together in a meaningful way. For example, we can take the left driving wheel and large motor, and that's a submodel. We can take the right driving wheel and large motor, and that's also a submodel. And now I'm going to connect these two. So I'm going to align this red piece with this red piece. So let me do that. And there. And oh, okay, move to the back. This wheel here is also a submodel. In this one, I have to align the black protruding part with the center hole there. Let me move it in. There. That works. And the last part is the brick. And the brick, I need to align the center right here with the black part here. So I do that. And here. Yay. Now we built an EV3 robot digitally. Thank you.
Okay. Okay. Now it's my turn to go. Okay. So I'll be talking about like the different types of CADing softwares there are, and then like different comparisons. Okay. So my name is Max Fan. I'm a 10th grader at Lebanon Trail High School. This is my 10th year in FIRST and my 4th in FTC. I am the CAD lead of the team 8565 TechnoWizards, and some hobbies of mine are tennis, reading, and playing video games. So just some topics to go over in my presentation are what is CAD, CAF software comparison, and the different types of FTC robot animations. So we'll just watch these two short videos about what CAD is.
And what you're able to do is to basically use lines, different circles, and you build the likeness of a product, and you can make it three-dimensional. You can look at it from all different angles. It's basically, you've got a picture of that model that you can look at in any direction.
And now the second video.
CAD, or Computer-Aided Design, is the use of computer systems that enable a designer to design anything in real time with accuracy. It has become an important tool for designing and drafting. With the use of CAD, it has become easy, especially for architects and engineers, to design any imaginary model of a building or infrastructure and to predict structural problems and find solutions even before they arise. Traditionally, pen and scale were used for drafting only a 2D image of an object, but with CAD, a 3D image of any object can be drawn. The big advantage of using CAD compared to traditional methods for designing is that it gives flexibility to manipulate and change the design in a fraction of the time.
Okay, so those are just two short videos about an intro into CAD. So of course there are different CAD softwares out on the internet. Lego Digital Designer is one, and then also LeoCAD, which we talked about. PDC Creo is one that our team used in previous years, but the one we're using right now is Autodesk Fusion 360. So here are just some different types of CAD systems. Like I know Sophie and Alex just talked about LeoCAD, which is a really good software if you're just modeling Legos. But another one that's useful to design Legos is Lego Digital Designer. And this one is actually made by the Lego company. So if you just feel better about using their software, then go for it. But our teams just use LeoCAD. And as I said before, for FTC, we use Autodesk Fusion 360, and we think it's really good because the UI is really organized. It's cloud-based, which means all of the entire team can work on a single file at the same time, and it's really easy to use. So here are some images of our past FTC robots. This is the one that I made last year in Fusion 360, and these were our robots in previous seasons, which were made in PTC Creo. And here's just a short video of a CAD simulation that we made in PTC Creo. And this is just animations that of the mechanisms on a robot, and we just put text over it to explain what each mechanism did. Now we can go into animation. So in the summer, our team did a summer project study, and my project that I studied was different types of animation. In specific, I chose the software Blender, which is another 3D modeling software that's really good for making custom parts and animating, but it's not as useful as Fusion 360 when you're making or like designing an entire robot with multiple parts. So we can just watch these two comparisons of the animation. And this is the Blender. And you can see in the Blender, it's a lot more organized. It has a lot more colors, which makes it look a lot more visually appealing. And it just looks a lot smoother than the 361 did in general. And that's all I have for my presentation.
Okay, I'll go next.
Yep, please.
Okay, can you guys see my screen?
Yes, sir.
So today we're going to be talking about Fusion 360 for assembling robot models. My name is Adrian Lin, and I'm on team 18227 ACP Area 52. I am a builder. I go to Curtis Middle School. I'm a 7th grader. I've done 1 year in FTC, so this is my 2nd year, and then I've done 2 years in FLL. So the agenda for today, we're first going to be talking about pan, orbit, and zoom, and then we're going to talk about the joint function. So first, pan, orbit, and zoom. So all of these functions we'll be using with the scroll button on your mouse. So pan is how you will use or how you will move your model up and down or left and right. Then you do that by pressing the scroll button. Next is orbit, which is how you will turn your model around. On your keyboard, you press shift and then the scroll button. And then zooming in and out, you just use the scroll wheel normally. So it's like you're scrolling up and down the page. So the joint function. The joint function allows you to connect two pieces together. There are a lot of different types of joints, but the two main ones we're going to focus on is first the rigid joint, which connects two pieces, and think of it like screwing them together so they can't move at all. The next one is the revolute joint, which connects two pieces, but it can rotate or move in a circular motion. So it's kind of like a wheel and axle. So if you open up the joint function, this is the first thing that pops up. Over here are the two different pieces that you can select. And if you go over to the motion tab, then over here are all the different types of joints, but these are the main ones, the rigid joint and the revolute. So the model that I'm going to be showing today is the mini-bot. This is the full model, but we're only going to be working on half of it. And we can go over the Fusion. So again, this is the full model. So if you press the scroll button on your mouse, you can move side to side or pan. Press shift on your keyboard, then the scroll button. This is orbit. And then last one, zooming in and out, you can just your scroll wheel. So if we go over to top the half of the robot, so this is half of the robot that hasn't been finished. So first, you need to move the pieces into your model. So there are all of these pieces at the side, and the one we're first going to do is this bracket. So there are two ways you can do this. You can first right-click and then press insert into current design, or you can just drag and drop inside. Either way does the same thing. So now whenever you bring in a piece, you can move it around, and then you can also turn it into different orientations. And I'll just move it closer to where we're going to move it. Okay, and then you can just press OK. Okay, now we're going to talk about the joint function. So you can either go to assemble, click, and then press joint. But if this ever pops up, you just click capture position, and then the joint menu pops up. Or the shortcut, you just press J on your keyboard, capture position. So the first piece that we're going to connect, you're going to select this spacer. Make sure you hover over the rim, and now the plus sign is in the center. Now it goes clear, meaning we've selected it. Now move over so that you can see the bracket, then hover over the edge and select that side. And then you can see it connect. And now we're going to go to the motion tab. Right now it's a rigid joint, but this particular joint we want it to be revolute. So I can see it turning on. Click OK. Now we just want to move it over. You can highlight whichever piece, press M on your keyboard, and then that allows you to move it around. So now we're going to move in another piece over here on the side menu. So now we're going to be moving in this one. So this time you can do whichever way, drag and drop, or right click and insert into design. Okay, there it is. Let's just move it out of the way. Then click OK. So now we're going to press J on the keyboard, which is just a shortcut. It's a lot easier, or you can just go to assemble and J. Capture position. Now we have the menu again. You can just select the center of the piece, and then move over and then select the center of the axle. Okay, so this piece, we could go to motion. We want this one to be a rigid one, not a revolute. Go to position, and now this one is facing the wrong way. So if you press flip over here, it turns it around. Okay. So now over here we have these different arrows, and we want to slide it down a little bit. And right there is about where we want it to be. Click OK. And now there's one more piece that we want to bring into this design. And that's the shaft collar. You can drag and drop. And then move it over. Click OK. Now press J. Select the center of the shaft collar. And then select the shaft. Okay, you want this one to be a rigid. You can go to position and then slide it down. Okay, so now we're going to want to mount this front wheel onto this extrusion. There are a lot of ways to do it, but how I do it is press J and then select the center of this little bump. Okay, go to the extrusion, and then you can see all of these different lines. Go to the center one, and then you have two choices. The two side pieces in the middle. Select the middle one. Okay, so as you can see, the bracket is inside of the extrusion. So all you have to do is just move these arrows around until it's where you want it. Then to have a more specific measurement, you can just change the numbers on the side. Okay. So now we want to move it closer to the other wheel. So we can drag this arrow to the side. Click OK. Okay, so now these two gears, they aren't close enough. And the joint we just did, we want to fix that. So how you do that is you go down to the timeline, which is all of the steps that you've taken. Select the joint that you just did, right click, and click Edit Joint. This allows you to redo the form. This CAD just takes some guess and check, or you can measure it, but we're just going to do guess and check right now. Click OK. And that looks about right. So now that we have it all connected, if we run the revolute joint,